Welcome, everyone. This session is about, actually, I will not tell you what it's about. I will just introduce our speaker for today, who is, as I said, Dietmar from ColorLogic. Hi, Dietmar. And I will turn it over to you, and then you can take this away.
Okay. Share my screen here. Okay.
Perfect.
Okay, so people can see what I'm seeing. That's good. So this is about ZePrA 8, the newest version from our color server ZePrA. And I would like to give you an overview of what we have new in that version, and especially we'll talk about proofing. Because that's the main feature that we have included in that version of our color server. You might ask, why is proofing a necessary feature for a color server, as there are so many proofing rips out there? And indeed, that was our first reaction when our customers asked us. But mostly, after they explained the reasoning why they asked us, they said, basically, that now that more and more people are using ECG, extended color gamut, multicolor printing with not even CMYK colors, so all kind of other colors, like for example in ceramic printing, where CMYK is rather the exception than the norm. There is always the need to work with multicolor profiles, be it a 7-color profile, 8-color, or 6, 5, whatever you want and need. And mostly, if it comes about spot colors, there is as well the need to work with CXF data and spot color data with spectral data. And if there are some overprinting of spot colors with process colors or with other spot colors, there you need to have a good spectral color prediction model. And that's all that we have in ZePrA already for production printing normally. And those clients told us, okay, we have those proofing rips, but either we have to buy a very expensive additional module to be able to process spot colors and multicolor correctly, or we are a little bit limited in what those proofing rips provide us in terms of support of CXF data and multicolor support. And therefore, we thought, okay, what can we do against that? Or not against that, but rather, what can we do to help those people that they get good proofs for multicolor? And obviously, what we can't do in the color server is drive the printers directly. But what we can do is provide them with an already color converted, optimized PDF document converted to the proofing's output condition, to the proofer's color space. And then they can simply print that either on their proofing grip with disabled color management, or even with an RGB driver, if you think on those Epsons, Canons, HP printers that you can print with RGB. And mostly that works very well. And that it works very well, we have seen already in the Foreground Multicolor Forum, which was presented at the beginning of this year and was conducted last year, where we used the RGB driver for an Epson P5000 with the CMYK, orange, green, violet, that we simply drove as an RGB printer, profiled it as RGB, and used it to process our 7-color ECG print, iterated that, and got very close delta E's and probably one of the best results here for proofing with an RGB driver. So not necessarily very expensive rip needs to be used for that. So and what I would like to give you here in this Zoom discussion is to show you a little bit how this has been done, and want to show you some of the features that we have integrated in ZePrA 8. So I talked a lot already, and you haven't seen anything else than this input slide here. So I just give you an overview of what we are going to look at. We are looking at printing such a nice guy here, just a CMYK guy. We have another one here. So that has an output intent from ISO-coated. We have another one here that probably have seen if you've seen my other presentation, where we used the same image here for production printing to convert it to a 7-color indigo. Here I'm using it as it is currently. It is an output intent ISO-coated. It has 3 spot colors included. There's one special spot color, which is not really important for the color rendering, but rather for the production upstream, for cutting and so on. So there's a die cut line, but basically it's a 6-color process, so to speak, because we have CMYK and we have additional spot colors that are overprinting the CMYK parts. So when we predict how that looks like, in reality, we need to predict it in combination with the CMYK under those spot colors. So we'll have that here. And in addition, I will use as well a 7-color image that I have prepared already, converted already to 7 colors. As you can see here in the layers, it uses the additional orange, green, and violet to extend on the gamma to make it more vibrant and looking very powerful in colors. Obviously, I'm using Photoshop here, which doesn't show us the colors in true reality, so it's oversaturated and so on. But that's just Photoshop. It's because it doesn't show us the colors for 7 colors here correctly. But this one I will as well use for proofing for our Epson P5000 in my example here. So let's set up a workflow for this. And as always, with our color server, we have the home button here. And with the home button, we can start with the auto setup. And inside the auto setup, we have different setup modes. And one of the new mode here we are looking to is the proofing mode. And we are continuing and can either use an existing device link profile. This is interesting for guys that have created the device link up front. For example, that iterated a proofer to the closest delta E, which can be done, by the way, with CoPRA. In CoPRA, we have the iterate module here. So you could create a device link and iterate it until you have the closest delta E. And that device link can then be used inside CoPRA, inside ZePrA, sorry, for the conversion. So let's move that back. Here I want to start from scratch, and I use SmartLink here to build the device link on the fly. I want to use, as a simulation color space, a 7-color indigo. Here as a sample, I'm setting up the prefer output intent here as well for my other files that I had here, which have used ISO-coated. And my target color space is a proofer here, Epson P5000, that I've profiled. And that would be my basic setup. Typically, you would have to select a SmartLink method, so the method how the device link would be calculated in the background and the rendering intent. But for proofing, well, the rendering intent is absolute colorimetric, so no need to select that rendering intent here. And basically, you don't want to have all those fancy things like exceptions and preserving separations. So all those additional things that you can do in a device link are of no importance either. Therefore, no other option here to choose. So it's quite easy, basically, just source color space and target color space. And one thing you would need for a proof would be a media wedge. And here we have 2 options. We can select an external media wedge, which could be the foreground media wedge, could be a TIFF file, a PDF file. We deliver as well the ideal lines CMYK strip, which comes for free, and that is as well integrated in the installer of ZePRA. And the other one, which is even more interesting, would be the dynamic media wedge, which would, depending on the output intent and the spot colors in the document, create a media wedge that consists of the color space of the document color space, the simulation color space, plus the spot colors. So that would be a dynamic media wedge, which is what we would want to use here. So that's nearly done now. So we just need to give it a name, 7-color indigo, and it should go to the Epson, to Epson 5000. So that would be our setting here. Another thing I can do with that auto setup wizard would be a soft proofing workflow, and we will do that as well, depending on how timing will be. So let's do this first. Now, if we remember, there have been some spot colors. So before we can actually proof those files that we had here, I need to go into my spot color library and define the library that I want to use. So typically, if you're new to ZePRA, the spot color libraries, that's something that you have to fill in. So as a start with ZePRA, there is no library in here. So, but you can fill it with all kind of data that you have, CXF, X4 data, for example. You can load Pantone libraries. If you have a Pantone Live access, then we have access to that as well and can load a Pantone Live library like this one, which have always this little icon here that indicate that it's a Pantone Live icon library, and we would load that. And obviously you can load Pantone libraries from other sources that you could have with your instrument, and you can load them. Even ACO files from Photoshop can be loaded. We prefer, obviously, spectral data because that's the best quality conversion you can do with. And what I want to use is this spot color gradients XF that I have incorporated already, which has my 2 spot colors I'm looking for. First of all, here, the Pantone red, which is only a solid color. If I look into here, I see it has only a full tone here. So I don't have information about gradients here. That's the least information I should provide to the color server so that he knows how that spot color can be or should be converted. So that would be my target LIB values. And for the Pantone Reflex Blue, I have some more information, like the full gradient information. So if I have that information, that's even better, because then I can as well have target values, for example, for the 50% value, which gives us this LIB values. And I want to target that value, and the color server would use that information. And even better, if I would have even some information like printed on black, which is then a full CXF X4 data. If we have all this information, we can as well calculate the opacity from that information. And ZePRA would then know, okay, that color is has a certain opacity. So if it interacts with a different color, the other color will either shine through or will be blocked, depending on how opaque that color is. So this information can be available with the information on black. We can override this. So if you are overwriting this and saying, okay, I have a different opacity because I have that information, or I want to try a different opacity level, you can override that. And then it will be shown here, and that's as well a new feature that we have included in ZePRA, that either it is a calculated, automatically calculated value, or a custom value if you override or define your own opacities that you want to use. So we need that spot color library here, and we need another library here, which I called non-printing colors. And this one includes my die cut, because my die cut, well, that's not a color I really need for conversion. And here I can simply define this is a non-printing color. So we shouldn't convert it, and we don't want to use that as well in my media wedge. I don't want to have a die cut in my media wedge as a spot color. Therefore, I can exclude it with that little option here, and I need a spot color library for that. So I need 2 spot color libraries in my configuration. And how to set this up. By the way, there's a new feature as well. This little browser icons here. With that, you can navigate like within the browser from each window to the next you have been in. So that's easier and faster than going to the home button and to the overview button, and then you're here again. So you can do this way as well. So another thing, how to navigate with ZePRA is, if you want to go to the configuration itself, you simply select that configuration, double click, and then you're in that configuration. And then there are a few tabs to look into. I don't want to go through each of them. The most important one we are attacking here, first of all, would be the spot colors and the proofing tab. But I want to start here. So that little checkbox here is quite important for our use case, because we want to use one proofing queue and want to throw in 3 different files with different sources, like iso-coated with spot colors and 7 color in one queue. And this can be done here with that little checkbox and with the default 7 color space if there is no output intent, like in our TIFF file. There won't be one, and therefore it will use that color space as the source for the conversion. So that's how this is set up. We are using absolute colorimetric for proofing. We have a smart link method called proofing for this, and that's good to go. Under spot colors, this is where we are now, where we need to select our spot color library. By default, we are using already, if available in a PDFX document, CXF data. If that's available in that file, we would use that information. That's the best information you could get. Therefore, it is used as the first step here. We don't want to use the lab values here, which is a default setting here. We can disable that. And as we want to use our spot color library, I'm looking through my long list of libraries. That's the one I want to use. And I want to use that on top. So that's the first library I want to look into. So the logic here is ZePrA would first look into that library. If it finds the spot colors in there, it will take it. If it doesn't find it, it will look into the next selection here, which would be that. Then you could select another and another and another library, and all those ZePrA would look through until he finds all his spot colors. And if there are still some spot colors which are undefined, then you would go to that section, undefined spot colors, and here you can say what you want to do with that spot color. For example, in our case, where we have this die cut line, we don't care about the color accuracy. We just want to see it in the proof. Therefore, we could as well use that method here to convert it to with the alternate color space, and we don't care about the color. It should just be there, so we use that. As a calculation method, we are using the precise match option here for proofing, so that's all fine. There's nothing to select here differently. For production printing, that's obviously not the right option here. If we are in production printing, we would use either this option here, use maximum of 3 channels, use this option, or use that, depending on our output condition. But for proofing, we want the best quality. Therefore, we are using that. For the gamut warning, this is typically enabled. And for production printing, for example, we are using a delta E limit of 2.5. For proofing, we want to have a narrower limit. You can set this even higher or lower if you want. So it's depending on our proofer here. So that's all fine. Special options, perhaps there's the auto setup will set this up for you already. Here you don't have to care about that, but there's at least one thing you should understand, and that's the reason I'm going in here. The merging color space. And this is the color space, for example, if I'm going back here to my CAD image here, this has an output intent iso-coated and has those 2 spot colors here. And those spot colors, if I would print it on my offset print with iso-coated with those 2 spot colors, the merging, the combination of those Pantone colors here with the CMYK would be done in that iso-coated. So it would be in my simulation color space. So in my printing color space, basically. And therefore, we have the possibility here to say, okay, where should that merging appear? Should it be done in the document color space? In our case, for proofing, it would be our document color space, or I could do it as well in the target color space, my proofer color space. And obviously, for proofing, that's not the right choice. We want to simulate how the print would look like and not how the proofer would merge the spot colors. Therefore, the auto setup would select that option automatically for you, so that you don't have to care about that. For normal printing processes, that would be the default. or automatic, basically. But we would use it then for the target color space. For the linearity, we have as well options here to define how the linearity should look like, especially for this one spot color that I had here, which hadn't any tint values. And for non-tint values, the ISO 2654 is a good method to use. And I'm going to use that here now too. The other ones are of no big importance here, but those two options are possible to select, either automatic or this one. I will use this one here. And so that's the spot color definition. In the proofing tab, we have two media wedges that we could enable. By default, we want one media wedge that simulates how our 7-color or CMYK or whatever we put into that queue is converted. So that's the most important one. There is as well a possibility to use a different media wedge for the proofer color space. This is useful if you want to check how consistent your proofer is. Let's assume I have created my Epson P5000 printer profile at a certain time. After that, I have changed my inks because I had to, because the inks are empty. Now the question is my profile still valid? And with this little additional media wedge, which would not be color converted, I can simply measure and compare it to the same media wedge that I had before that ink change and see how strong the deviations are. If they are low, I can still use my printer profile, no problem without that. If the delta E's are high, then I better create a new printer profile for my proofer, because otherwise my proof quality would not be that high. And therefore, we have a second media wedge. I just use this one here. And obviously, I need some proofing information, which we will add on the proofing page. And we would add it at a certain position, and that position can either be automatic or one of those margin options. We add the media wedge and information to the external part of the media box. So that can be defined where that is. And there's just one thing here that we need to define. That would be under options. And here, the important thing is where our second spot color library would be selected. To exclude colors from the dynamic media wedge, we want to use a dynamic media wedge. And if you remember, we had those 3 spot colors, and one was a die cut, and a die cut is definitely not a spot color we want to have in our media wedge. And therefore, we select our non-printing color library here. Oh, I should look for N, right? So where's that? Here we go. So I select this one. And here would be, that would be my selection here. I can as well say how many tints I need in my media wedge. I could have the solid tones only for the spot colors, or even none if I don't want them, or 5 patches. I will add 5 here. Can be fine if I want to have gap size or not. The patch size can be defined, and the ruler definition would make for the default chart width. That's a typical dimension here that we would use for the I1 ruler, for example. The font size can be defined, and so on. So that's all done here and fine. So I'm now done with it. And now let's see what's happening if we are converting our files. So here again, I can simply right-click on a queue, open folder, and with that, I have the input folder. And from there, I want to put in my 3 files. And they are now going to be processed. There is as well one thing that we are setting up during the processing here. We can look into that in the edit queues. We see here that there is a folder for report and other data. So this report folder will be added from the auto setup wizard automatically. And that's an important folder here, because in that folder, we will position the reference data for our media wedge. Because our media wedge is a dynamic one. that we are creating here. And for each of the jobs, it will be a different media wedge. And for each of them, we need the device color data, and best would be as well the LIB data, so that we can compare our result at the end. And so that's what we are seeing now, what's going to happen here. So all the files are converted. They are now in the output folder. And here under reports, we have the text file from our media wedges. And let's have a look. Perhaps we start with our dogs image here, which has been converted to RGB, our proofers in RGB color space. And what we are seeing here is that we have added a CMYK media wedge. We probably, if we zoom in, we probably even see a little bit of paper simulation here. So here is a white, and here is some paper simulation that you can see in the RGB values here. This is the media wedge. This is the information part, the job information for the media wedge with all the information that are necessary to make it a real proofing thing. This is our media wedge, and we would add that media wedge below in this example from that image. So that's a CMYK media wedge. From the cat food one, let's have a look here. How would that look like? Again, everything is RGB, obviously. Here we have our CMYK media wedge. We have our information placed here beside, and we have 5 tins for our spot colors red and blue. Obviously not the die cut, because we have excluded that. So we have this information here. And the last one was this image here. If I open that in Photoshop, we'll see it is converted to my Epson. The profile is shown here. We see it is RGB. And here we have a larger media wedge because, well, our source color space was 7 color. And therefore, it is a bigger media wedge with more information that is needed to be placed in here. And here again, it has a paper simulation added to the media wedge, the same as it would be applied here to that image. And as we can see, that was the original viewing, the way how Photoshop views this multicolor, but it's not in true color, but that's rather how it would look like in reality. So vibrant colors, of course, but more true to reality, and that's what we can see here. So that's very nice. And if I'm going to look into those media wedge information here, we can simply load this in ColorEnd. ColorEnd is as well a tool from us that deals with measurement data. And we can simply load the 3 data here. And we will see exactly the same thing, starting with this fine print Drotel poster, which was the CMYK part. We would see it has CMYK information. That's basically the layout as well from our media wedge. We could measure this as well here with our own tools and compare it with the comparing feature to see how good we are in proofing. Obviously, I don't have something to compare here, but this gives us already the information, all the information we need to measure it and to compare it to the LIB values, and we will fill this information automatically. So that's really a very nice functionality here. Our cat food has the CMYK plus the additional 2 spot colors here. Here again, we have the LIB information that we want to target, and we can check with our proofer how good we are in representing these colors. And the last one, obviously, was a 7 color media wedge, and here we have all this information as well. So the bigger information here with the media wedge for 7 color. And all this is automatically created from ZePrA with all the information available so that you can work with that either directly in ColorEnd for measuring or use it in whatever kind of evaluation software you're using. Simply load the data because it's CGATS data, just some normal CGATS data that everybody should be able to read. And with that, you can import that in any kind of tool measure, and you get your evaluation with that. So that's how this works in ZePrA. I just want to show you one little thing here. If I'm changing, no, I'm changing the patch information here, that only the solid tone for the spot colors should be added. I just want to do that to give you an indication what's happening then. I just want to convert this file, the cat food file with the spot colors. Simply in the process jobs area, you could right-click repeat job, and then the file can be processed again in that folder so that you don't have to search for that. Open folder here. So what's happening now is that we will override the existing cat food text file here with the new information, so that now we will have a different reference file with just the spot color from the full tone and not with the tints anymore. This way we make sure that the last kind of conversion that you want to do really is reflected as well in your reference file here. And after the processing here, I would just load that so that we can see what's happening. So this one, the cat food, has now only the full tones for red and blue here, whereas before it has the 5 steps of our spot colors. You know, so this way we have the right media wedge for the right purpose, let's say. Okay, so that's the proofing part. One thing I would like to show you, which is as well new in ZePrA. So these are other features that we've added here, but it is a little bit related to that, because here in the overview, we have, if you click on that little arrow here, you can select what we call tags. So we have, I have created already a few tags already. And by selecting that tag, only the cues which are tagged with the name proofing are shown here in the long list of configurations. This way you can find your configurations faster. Obviously, the last one that we have just created haven't been tagged, therefore it doesn't show up here. What we are going to do now is show you how to do that. Under options, we have the nodes and tags. You can define a node and as well a tag. And here with plus, you can tag it with proofing, for example. And with that, it is then faster and easier to find in the overview. For people that knew ZePrA 7 and older versions, it was always not that easy to navigate through the large list of configurations, because typically the configurations are sorted according to their appearance. So the first one was obviously was this one, and the last one in my list was the one we just created. Here, this one. And now we have possibilities to sort it alphanumerically, which makes it a little bit easier to digest, let's say. And the other thing is you can really search for names here that you type in, and then the namings and the listing will be much shorter, and only those that are using the proof name, for example, will then appear in the list. So that makes life easier. And the same we have done in the queues. Here you can as well search, and you have the same sorting functionality here as well. So that has changed in the user interface a little bit. Another new feature in ZePrA 8, because this one is about ZePrA 8 and its new functionality, is that we have what we called the equivalent profiles. And I have selected a queue here. And this is something which is, yeah, let's say not only unique to ZePrA, but really a nice way of thinking and of color managing. Because typically, if you're converting from iso-coated to iso-coated, ZePrA would call this a null conversion, also don't convert. Yeah? So if somebody wants to convert from iso-coated to iso-coated, well, then we think it doesn't want to convert. And this is a good logic, because typically, if you would convert it, then you would have slight deviations, and your rendering will destroy original color situations here. That's a logic that many tools follow if they think about it correctly. So that's fine. What we do as well is we maintain internally a list of what we call equivalent profiles. And for example, here, a coded FOGRA 39 from Adobe is an equivalent profile to ISO-coded version 2 ECI. Or there's another ECI profile, which is the 300 TAC version, which is as well an equivalent profile. And there are a few more of those. And if you think on all those others, there's a few Greco profiles which are targeting the same source information, the same CGATS data from which that profile is built. And therefore, we would regard this as equivalent profiles, and therefore we wouldn't convert between those color spaces. So, for example, here, if I select this one and I would select here this one, for example, we wouldn't convert between this profile and this profile. In some situation, this is wanted. And therefore, we have added a little checkbox here, which then would override that rule and would still convert. So in this case, you could convert from ISO-coded to ISO-coded version 300. And with this little checkbox that we've added, this is now possible with the smart link conversion. So that's as well new. And we have added that in what we call the profile assignments as well. Profile assignments, that was our technology that we have introduced, I think, in ZePrA 3 or so, before we had the smart link functionality. And this was the way to apply a device link on a certain combination of source and target profiles. So in this example here, it would say, whenever there's a piezo-coated embedded or from source to destination or from document to target or an embedded profile from whatever direction, from either to document or to target color space, if this kind of two combinations are used for all rendering intents, maybe as defined here, then this device link should be used. So this way you could create your own individual settings for a certain conversion. For example, you could create a device link that you want to use for vectors only with high saturation rendering, whereas for images you want to do something else. You could define that here by applying that only to vectors or to image or to both, as in my example here. And here again, we have that little checkbox, because if the target color space is coded FOGRA 39 from Adobe, for example, which is an equivalent profile to ISO-coded V2, with that little checkbox, this device link would be applied to. And this way, you can make sure that the same device link is used for all kind of equivalent source and target color profiles. So that's the way how that works. And this this profile assignments can be applied to all configurations, and that's as well the danger of that let's say, because if you want to use it permanently, it will happen that in some configurations it will be applied as well. And therefore, I typically suggest not to use it here and to apply it all the time, but only in situations where it is necessary, and then you can apply it here. This list is typically empty and needs to be filled as well from with your profiles if you want to use that. With the smart link option that we have included since ZePrA 4, this is less and less needed, let's say. But sometimes still our clients love it, because they can really apply the device link that they have built and that they have maintained and that they have tweaked, and they want that device link to be used, and they can make that happen by using it here with the profile assignments. So that's it. That are the new main features in ZePrA 8, proofing and a few production features, let's say, and a few features to make it easier to navigate that we have included here. And I would be happy to hear a few of your questions.
Yeah, there are a few questions already that were in the chat. I think you also answered some of them already.
Good.
But let me make sure and go over them. And if someone thinks that their question is not answered, please correct me. So on the dynamic wedges, does it provide a solid or tints? I think we've seen that it can do both.
Yeah.
And will you honor the tints when you have CFX4 library? I think we've seen that as well, both for printing on white and on black even.
Yeah.
And the answer to that part of the demo was awesome. So that just so you know. I think, Axel, your question was answered as well. Again, if not, please speak up. And then another one, when you were talking about the proofing part, question is, I guess I could convert to monitor color space and view accurately using this as well.
Mm-hmm. Yeah, okay. I mentioned at the beginning, if time permits, we could create a soft proof queue. Mm-hmm. If time permits, I could create such a soft proof queue.
Yes, I think that would be interesting.
Okay, so yeah. So let's take our sample here from our cat food and create one that we want to share with our clients, so that they see how our original, which is shown in Photoshop like this, with as we know, sorry, Photoshop, in Acrobat, which we know that Acrobat can't display spot colors accurately. So we have our two spot colors here, but they are somehow displayed here, and the overprints are somehow displayed, but really not how it would really actually look like. And therefore we could as well misuse, let's say it this way, our proofing functionality, or use it this way by simply creating a new queue, which we are using ISO-coated, for example, because our output intent was ISO-coated. Here we could prefer output intent, so I could have selected something else, and then ISO-coated would be used as well. Here, as a proofer color space, I would use a reasonable big color space like Adobe RGB, which can be used as an output. And well, a media wedge I don't need. And this would be my soft proof.
If you had a profile for a specific monitor, I guess you could select a profile for the specific monitor.
Select that too, yeah. However, then you're a little bit more limited, let's say, to that monitor specifically.
Yeah.
And therefore something like a working space makes more sense, because that one will then be shown on your monitor as well, and from Acrobat. So the Adobe RGB will be rendered to your monitor screen if that's profile. So it's quite better to use something more generic, let's say. Could be ECI RGB or well, it should not be too big, let's say this way. It's something like a Pro Photo RGB, which no monitor on this world can show perfectly, is probably a little bit too big. Then it should be a color space that your monitor can maintain somehow, and that is big enough to simulate the spot colors. And the Adobe RGB will do the trick here in our example. So that's our soft proof queue. Let's have a look if we need to do something here. There was this die cut line. First of all, we need to select our spot color library. Spot colors, we want to use that. We don't want to use that. And the undefined spot colors here again, I would simply convert this to the alternate color space. Here I don't have to do anything. So that's just what we want to do. The spot colors we have just defined here. We don't need the media wedge, because we want to provide that data to the client. We can think about if we want to have paper simulation so that we see it with paper simulation. I would think that's the right thing to do, but we can as well use a relative, so without the paper simulation. But I think that's the more reasonable here to select. One thing we would do is to rasterize the document completely. By the way, that's as well a new feature, this little checkbox here, because we are using, when we are doing the flattening or the rasterizing here, ZePrA would look into the file, and if there are transparencies in there, it would apply or would raster or flatten. If there are no transparencies, it would leave it as it is, so it wouldn't change anything. And if I want to make sure that my file is really rastered, then this little checkbox helps to do that. Here can define if I want a pixel file or PDF, I just leave it to PDF. Resolution, yeah, if we can make it a little bit smaller for a monitor, but it's fast enough, we can have it this way. This way it's done. And here we go. And we simply need to put the file into the input folder here. And let it convert. We will get it in the output folder after conversion. And that will be then a simple kind of conversion, making sure that our spot colors are converted to our output. And the file, if we have a smaller resolution, would be so small that we could provide it as a PDF for our clients, so that our clients can have a view on our artwork with the spot colors rendered correctly. So that would be a nice way of compensating, let's say, the deficiencies that Acrobat has in terms of rendering spot colors correctly. And this way, if I'm opening that here, so that's all RGB. So we can see, oh, how vibrant our orange, our reds and our blue is compared to how it was rendered here before from Acrobat, this really grayish blue, let's say. If I switch back here to this one, I can see how good that looks like. I can see the overprints here. I can see really a nice view. I have paper simulation as well included here. And this file, let's see how big it is. 17 megabytes, so that's probably a little bit bigger. So maybe we have to select something like 100 dpi or 72 dpi's, let's say, and then it would be smaller, and we can provide it to my client so that he has a good idea of how that file looks like.
But it's a rasterized file, correct?
It's a rasterized file, right? Mm-hmm. And we could even, if we change it here to be a TIFF file, so it could be provided as a TIFF file as well, or a PSD file, depending on the settings.
But it's given the fact that it's rasterized, that would mean that so the spot colors are going to look correct. You're not going to have any problems with overprint rendering or anything like that.
Exactly. Yeah. To avoid that some renderer has to do something with that spot colors, which would be included in there, or which are in overprint mode or something. We would simply rasterize, and then there's nothing to interpret anymore.
Would it show correctly in something like preview?
Yes. It just, well, we have the output intent, the Adobe RGB embedded. So if the preview would honor it, I'm not 100% sure if it does, but I think it does.
It does, actually.
Yeah, then it should be the same that we're seeing here in the preview as with Acrobat. No. I think that's a very simple and nice functionality to help in the designing process. If you can send something to your client that really shows how it looks like, and
and I think if they then open the file in preview, it's going to look at least reasonably correct. But if they open it in Acrobat, it's going to be entirely accurate. So that's a big advantage, I think.
Yeah, indeed. Cool. And here again, I could then say this is a proofing queue, and it would be in my list of proofing queues. And here, by the way, the tag management can be managed here if I want to rename it or want to delete something, and I can manage that all here. And I can see as well, I have 14 times the tag used for proofing here, for example, and so on. And this way, I can manage this as well. No.
Okay. There was one additional question, but I am not sure what it refers to now. Ricardo, if you if that has not been answered yet, would be nice to have some more details. The question was, what would be the best method to print the file. Ricardo?
Yeah, I mean, after we have the proof file, where do what's the best method to print it? Like, do I print it from Adobe Acrobat? Do I print it from where do I print the file?
Yeah. So in my example here, which I used here, which is an RGB basically, and I used the RGB driver. And as this is the PDF, you can as well print from Acrobat basically and disable the color management part. There is somewhere an option to disable the color management when printing, because the color management has basically been done.
Yeah.
And you could do it from Acrobat. If, for example, you are using, let's say, a RIP solution like GMG or EFI and some other solutions, they all have the ICC profile of the paper and the proofer that they're using. We could use that as well here. And then if we would use those RIPs, they have mostly hot folders. So you could put that PDF file in the hot folder of your proofer, disable the color management in the proofer, and then simply print with your existing RIP. So the RIP would then be, yeah, let's say, used as a simple printer, but it would be a very nice workflow as well. You know? So you could use your existing RIPs. We don't put them away. We can simply use them, their functionality, and with the hot folder functionalities of them, this can be automated. And of course, you could use the nesting and all those fancy things that those RIPs can do with that as well. That is the way of how we cope with the existing installations, let's say, that a client has.
Yeah, the only thing you take over from the RIP is the color management part
No.
that you can then switch off from.
Obviously, if it's a simple thing like CMYK conversion and so on, well, all those RIPs do a reasonably good job. There's no need for that. But if it comes to this special things of spot colors and overprints and CXF and all this wonderful new things in our printing industries that ZePrA can handle, we can help and use their existing RIPs without having to look at other RIPs. Let's say you could use a simple Visage RIP or those low-cost RIPs, let's say, and make them a proofing RIP with if you are already a ZePrA user and using ZePrA for production printing, now you could use it for proofing as well. So that's a little bit the idea here that we provided.
Thank you.
You're welcome.
This is not typically my kind of question because it's more on the commercial side, but I know you have multiple versions of ZePrA. Where does the proof option fit in, or is it just available in anything, or how does it work from a commercial point of view?
Yeah, it's already in the lowest version, which is our entry version, which can process only TIFF on pixel files, and it can be used there. And so it's all in all modules. And if you want to use the multicolor is obviously the one that with the highest price, but it has not to be purchased in addition, let's say, to an existing ZePrA. If you want to do that proofing, it's always in.
Yeah, okay.
With that, you can do it for CMYK or depending on your multicolor license as well with multicolor.
And an existing customer who upgrades to version 8 would then have the new possibilities
exactly
in version 8. Okay, that makes a lot of sense. Any other questions from anyone? I think we have. You can feel free to disagree with me, but I think we answered the other questions. No? Good. Then, no. So thank you very much, Dietmar. I think this was exactly what we were looking for. And
thanks.
Judging by what I read in the chat window, people were impressed. So that's very good. So thank you very much for that. To everyone who attended this, thanks for joining once again. Have a great rest of the day.